On the way to my classroom, I walked down the long corridor, past the hundreds of books, their pictures, jackets, colorful and bright. Each one a window into the worlds I have never visited. I can see the elephants on a plane in Africa, a jet airliner cruising, waterfalls, icebergs, and cavemen fighting a saber tooth. Such places, such worlds. I see the grey November sky, rows of houses, chimney of closed down factories. I'm always willing to take the register to the office, to walk down the long corridor and gaze once again through the book, jackets, windows into the worlds I have never visited. A great poetry by Wes Maggie, born in 1939, Green Cork, United Kingdom. An amazing depiction of a student's wildest imagination through the windows of the books, and how he visits the unvisited, unseen, unexperienced, unimagined places and worlds. That's simply enthralling. Let us see through the window of today's topic. What does it unravel for all of us? Well, that's the introduction to the G protein coupled receptors. Welcome all to IS Pharmacology Difficult Podcast. I'm your host, Dr. Radhika Vijay, MBBS MD Pharmacology, and this is the audio hub to get the best simplified basic tips, strategies, methods, and lots of ideas to learn better, understand better, and make your concepts crystal clear. If you really find, and if there's a question hovering in your minds, is pharmacology difficult? Lend me your ears for a while and let in the magic of knowledge. First and foremost, a quick review about the receptor nature and its types. Heteropolymeric nature of receptor changes because of the binding of the agonist. When the binding of the drug occurs to the physiological receptors, the responses are sent via hormones, various neurotransmitters, etc. And then there are some wonderful receptor sites for which there are no known physiological ligands. And one classical example for such types is benzodiazepine receptor. Another term is orphan receptor, that is used for those having no endogenous mediators or ligands. Let's comment on the classification and the types of the receptors. Alquist, a scientist in the olden era, differentiated adrenergic receptors into alpha and beta types. Now there were different criteria utilized to classify the drugs. The criteria, they were ligand binding, for which we have the result of the serotonin or the 5-HT receptors. Then one more criteria was molecular cloning that can be applied to the orphan receptors. A unique pharmacological approach can be utilized to differentiate among the muscarinic, nicotinic, or alpha, beta, etc. types of receptors. Tissue distribution divides the beta into beta 1 and beta 2 subtypes. Transducer ways makes the receptor act via segregated mechanisms, via second messengers, via G proteins, etc. Another term, silent receptors. They bind the drugs, they produce no response. And we can better call them as inert sites or sites of loss. Yes, a true loss. Let's enter the conference of the G protein coupled receptors now. GDP activated proteins, or simply G proteins. They connect the receptors on the cell membrane to either enzyme or the transporters or channels. It's quite interesting to know the structural pattern of the G proteins. It's very unique and beautiful in its own way. Every molecule of G protein is designed having 7 alpha helical membrane spanning amino acid sequence, and that sequence is actually hydrophobic in nature. Now just imagine these amino acid sequence running to the triple extracellular and intracellular loops also. Then there are specific sites for agonists somewhere in the middle of the extracellular phase of the helices. G protein binds to a special site that is composed by cytosolic elements. And now you just picture this whole thing with your closed eyes. G protein is floating in the membrane. Its domain is exposed. It lies in the cytosol and it comprises of 3 subunits: alpha, beta and gamma. Hope you got this picture. Let's learn a little more about these subunits. Yes, they are of great importance. Their attachment status decides the active or the passive configuration of the G proteins. If GDP, I repeat, GDP binds to the alpha subunit state, then the status is inactive, and once the GDP is substituted by the GTP, GDP substituted by GTP, then activation ensues. Guanosine triphosphate substitution ensues the activation, while guanosine diphosphate binding is responsible for the inactive state of the G proteins. Now GTP, it is bound to the alpha subunit in the state of activity, and then it dissociates from the rest of the 2, that is beta gamma subunits. It takes its own course to either stimulate or inhibit the effector. Now don't you think that beta gamma dimer state goes in vain? No, it does not. It activates the potassium channels instead. It may inhibit the calcium channels instead, and many more ways it acts. Now let's classify the G proteins on account of the variety of the alpha subunits. Well, around 17 have been actually known till far, or maybe a few more of them. But today we're gonna discuss only a handful of these. To start with, I have capital G small s. It leads to the opening of the calcium channels and adenylyl cyclase activation. The next we have capital G small I, that leads to the opening of the potassium channels and adenylyl cyclase inhibition. I for inhibition. Then we have capital G small o, that leads to the inhibition of the calcium channels. Then we have capital G small q, that leads to the activation of phospholipase C. Now activated effectors via the transducing mechanisms and via the second messengers, they produce their effects. Okay, did I just mention second messengers? Yes, I did. Okay, just guess what can be the first messenger. It is the agonist itself. Now the effector is actually stimulated or inhibited for a time duration which is much longer than the binding or the activation. And the whole signal is actually magnified. The regulator protein of the G protein signaling, which is abbreviated as capital R, capital G, capital S, RGS, it monitors not only the duration of action of the effector, but also the rate of the hydrolysis of the GDP. Well, that sounds very interesting. So we have a regulator protein of the G protein signaling RGS that is actually monitoring and regulating the duration of action of the effectors and also the hydrolysis rate of the guanosine triphosphate. Well, that's a quick revision. Now alpha subunit, it possesses intrinsic GDPase activity, which actually hydrolyzes GTP to GDP, guanosine triphosphate to guanosine diphosphate. The binding of the alpha subunit to GDP occurs that leads to further binding of this whole thing to the beta gamma dimer, and a vicious cycle goes on. Now you might be brainstorming the mechanism of G proteins. Well, no need for that. That's not today's cup of tea. Let's save the syllable to glorify tomorrow's cappuccino o'clock. Till then, jaunt through the upcoming day duo, Saturday and Sunday. Wish you all a very happy weekend. For all the updates and latest episodes of my podcast, do visit www.ispharmacologydifficult.com, where you can also sign up for a free monthly e-newsletter of mine. It actually contains a lot of updates about medical sciences, drug information updates, and my podcast updates also. You can follow me on different social media handles like Twitter, Insta, Facebook, and LinkedIn. They all are with the same name as Pharmacology Difficult. If you are listening for the first time, do subscribe and follow whatever platform you are consuming this episode. Stay tuned. Do rate and review on iTunes, Apple Podcast. Stay safe, stay happy, stay enlightened. Thank you.